Okay, so I want you to start by picturing a high-performance sports car. It's sitting in your driveway.
Hmm.
We're talking a masterpiece of engineering, V12 engine, perfect aerodynamics, built to do 200 miles an hour without even breaking a sweat.
I'm with you.
But there's a catch. The manufacturer has welded a governor onto the engine block. So it doesn't matter how hard you floor it, that car will not go over 65.
Ugh, that's a painful image. You own the hardware, you pay for the fuel, but you don't actually control it.
You're just a passenger in the driver's seat. Exactly. Now, imagine a mechanic shows up.
Okay.
And he says, look, I can take that governor off. I can do it in your garage in about 45 minutes with standard tools.
Mm.
And this is the most important part. I can do it without cutting the brake lines.
Or making the steering wheel fall off?
Right. That is the premise of what we're covering today, except we aren't talking about Ferraris. We're talking about large language models and a tool called Heretic.
And that name, it really sets the tone, doesn't it? Heretic. It's a piece of software on GitHub from a user called PEW. And the tagline is just so bold.
What is it?
Fully automatic censorship removal for language models. But what makes this so interesting for our deep dive isn't just that it makes an AI say forbidden things, it's how it does it. This is not a brute force attack. It's more like neurosurgery.
That's the key distinction we have to make right up front. I mean, we've seen uncensored models before, but they're usually a bit broken, right?
Yeah, they ramble.
They ramble, they forget how to code, they get stuck in loops. Heretic claims to solve that trade-off. So we've got the source code, the papers, the benchmarks. Let's open the hood. What is this actual mechanic? The documentation keeps using this term, abliteration.
Right, abliteration. It sounds like a move from a video game, but it's actually a combination of two words. Ablation, which in medicine is surgically removing tissue, and iteration. The whole concept is based on some 2024 research from Arditi and others.
Okay, so if we stick with that medical analogy, we're cutting something out. But what are we cutting? Is censorship just like a file we can go in and delete?
I wish it were that simple. In a large language model, refusal isn't some rule in a database. It's a physical shape in the model's brain.
A physical shape.
Well, a mathematical one. Think of the model as this huge map of concepts. When you ask it something it deems dangerous, like how to build a bomb, the model's internal state moves in a very specific direction. It activates a cluster of neurons that basically represent refusal. It's a literal pathway in the math.
So there's a specific I can't do that, Dave, circuit that just lights up.
Effectively, yes. And in a standard fine-tuning process, which is how companies usually add safety, you'd show the model thousands of examples to train it not to use that circuit.
You're teaching it a new habit.
Which is super expensive, thousands of dollars in compute time.
And slow. Incredibly slow.
Yeah.
You have to run the whole training process again.
Right. Obliteration is different. It doesn't teach the model anything new. It finds that specific refusal direction, that neural wire, and it just cuts it. The term they use is orthogonalization.
Okay, wait. Let's pause on orthogonalization because that is a heavy word to drop this early.
It is, yeah.
In geometry, orthogonal just means right angles, right? Perpendicular. How does making something perpendicular uncensored an AI?
This is one of those concepts that's way cooler than it sounds. So imagine the model's thought process is an arrow flying through space toward an answer.
Okay.
If the refusal concept is a strong wind blowing directly against that arrow, the model stops. It refuses. Orthogonalizing means we change the weights so that the refusal wind blows at exactly 90 degrees to the arrow.
So it creates zero friction. The wind is still there, but it's not pushing back anymore.
Exactly. The dot product becomes zero. The model literally cannot see the refusal instruction anymore. It's not that it wants to answer you, it's that the mechanism for stopping itself has been mathematically zeroed out.
So it's not overriding the safety. It's making the safety invisible to the engine.
That's a great way to put it. And Heretic targets very specific parts of the transformer to do this, the attention out projection and the MLP down projection.
The MLP being the multi-layer perceptron. If I remember from our other deep dives, that's the part of the neural net that's kind of associated with storing facts and knowledge.
Correct. And that is where the danger lies.
Right, because if you start orthogonalizing, if you start zeroing out parts of the brain that store facts, you might zero out something important.
Like how to use grammar.
Or the fact that the sky is blue.
Mm-hmm.
Or how to write a Python script that doesn't have syntax errors.
And that's what we call brain damage. It's the biggest risk in this whole field. The technical term is model degradation. If you just go in with the machete and hack out the refusal direction, you often take a huge chunk of the model's IQ with it.
You get the car to go 200 miles an hour, but the steering wheel disconnects.
Or it forgets it's a car and thinks it's a toaster. And the source material is really honest about this. Previous attempts at this often resulted in models that were, free, but also really stupid.
They'd answer your forbidden question, but the answer would be total gibberish.
Exactly.
Which brings us to the core innovation of Heretic. The GitHub page claims it solves this brain damage problem through automation. It mentions a TPE-based parameter optimizer powered by Optuna. That sounds like marketing, but let's break that down. What's TPE?
It stands for Tree Structured Person Estimator. It's just a fancy way of saying smart trial and error. Instead of a human guessing, oh, maybe I should cut 10% of this layer, the software runs thousands of tiny simulations. It uses a framework called Optuna to hunt for the perfect settings.
And it's optimizing for two things at once, right?
Mm.
It wants maximum freedom, but minimum stupidity.
The Goldilocks zone, yeah. It uses a metric called divergence. This is really crucial for anyone following open source AI to understand.
Kullback-Leibler divergence.
Right. It measures how much one probability distribution differs from another.
So in plain English, it measures surprise.
Yes. If the modified model says something that is wildly different from what the original model would have said, either grammatically or logically, the KL divergence score spikes.
Which means you broke something.
You broke something. You want that score to be as close to 0 as possible.
And the source has a comparison here that just drives this home. They tested it on Google's Gemma 312B model.
Which is a very capable but very, very censored model.
Right. Out of the box, Gemma refused 97 out of 100 spicy requests. It's a brick wall.
Almost 100% refusal rate. It's doing exactly what Google told it to do.
So they look at competitor tools, other abliteration scripts, and they worked, kind of. They got refusals down to 3 out of 100. But the KL divergence was huge, like 1.04 or 0.45.
To a data scientist, a KL of 1.04 on a text model is just... it's catastrophic. That's a lobotomy. The model isn't just uncensored. It's fundamentally a different, dumber thing.
And then Heretic comes along. Refusals, also 3 out of 100. So it's just as free. But the KL divergence.
It's tiny. That's an order of magnitude better.
A 0.16 divergence means the model is practically identical to the original, except for the refusal. It keeps the wit, the reasoning, the coding ability. It just loses the moral lecture.
That is the difference between a hack job and surgery. But how? I was looking at the under the hood section, and it looks like Heretic has 3 specific technical tricks that let it hit that number.
It does. And these are fascinating because they reveal so much about how these networks are actually structured. The first is how it even finds the refusal direction. It uses a difference of means calculation.
Okay, walk me through that.
It feeds the model 2 sets of prompts. Set A is harmless stuff. What's the capital of France? How do I bake a cake?
Right.
Set B is harmful. How do I launder money? Write a threatening letter. Then it looks at the residual stream, the internal flow of data, and it subtracts the average of A from the average of B.
So it mathematically isolates the difference between naughty and nice? Exactly. That difference vector is the refusal direction. Once you have that, you know what to cut. But, and this is the big, but most tools, just cut that same vector out of a bunch of layers equally.
A flat cut, like giving everyone the same haircut.
Right. But Heretic uses a flexible ablation weight kernel.
Which sounds like something from Star Trek.
It really does, but it's very practical. Instead of a flat cut, it allows the software to sculpt the cut. So maybe the refusal signal is really strong in layer 15, but weak in layer 12. Heretic adjusts the intensity, layer by layer. It's like using an equalizer on a stereo instead of just a volume knob.
Okay, that makes sense. It's a custom fit. But the second innovation is the one that actually made me stop and reread the notes, the floating point direction index.
This is the one that blows people's minds.
Because layers are integers, right? You have layer 1, layer 2, layer 10. You can't have layer 10.5. It's like saying you're parked on the 10th and a half floor of a building.
Physically, you're absolutely correct. The code has distinct blocks. But mathematically, that refusal direction evolves as it moves up through the layers. It rotates. What Heretic does is it allows you to interpolate. It says, what would the refusal vector look like if we were halfway between layer 10 and layer 11?
So it's calculating a theoretical transition state.
Yes. And it turns out, sometimes the absolute clearest signal of censorship isn't at layer 10 or layer 11, it's at layer 10.4.
That is wild.
Yeah.
It's finding a signal that doesn't exist in the physical code, but exists in the mathematical space between the code.
And by targeting that interpolated vector, that ghost layer, Heretic can remove the refusal with surgical precision without damaging the concepts around it. It unlocks what the creator calls a vast space of additional directions.
It's finding a radio frequency between the stations.
Perfectly put. And the third trick was component specificity. We touched on the MLPs earlier. The creator, PEW, found that messing with the MLP layers, the knowledge banks, causes the most brain damage. But modifying the attention layers, which control how the model routes information, is much safer. So Heretic treats them differently.
So it might go heavy on the attention layers to redirect the flow, but stay really gentle on the MLP layers to preserve the facts.
Exactly. It optimizes the weights differently for each component type. This level of granularity is why it gets that 0.16 KL score. It's not magic. It's just really, really extreme optimization.
Now, hearing all this, floating point indices, difference of means, you would assume you need a PhD in a supercomputer to run this thing.
You would definitely assume that.
But the user experience seems designed for, well, for me. The Riado says anyone who knows how to run a command line program can use Heretic.
And that's the democratization part. This isn't just a theoretical paper. It's a tool you can download right now, and it's really efficient.
The benchmarks mention running it on an RTX 3090, which, it's a high-end card, sure, but it's a consumer card. It's what you use to play video games.
Exactly. You don't need an H100 cluster. You don't need a data center. The source says Decensoring a Llama 3.1 8B instruct model takes about 45 minutes on that card.
And for people with even less hardware, it supports quantization. For the listeners who aren't hardware nerds, just explain quantization real quick.
Think of it like MP3 compression, but for AI. You take these massive high-resolution numbers and you compress them down. You lose a tiny bit of fidelity, but the file size and the memory you need just drop through the floor.
So you can actually fit the model into the memory of a normal gaming PC.
Yes, and Heretic can perform its surgery on the compressed model. That's huge. It means a kid in a dorm room with a gaming laptop can potentially create a state-of-the-art uncensored model.
And people are doing it. We have these testimonials from the community, and they are, well, they're colorful.
Yeah. They're enthusiastic.
There's one user talking about GPT-OSS 20B.
Yeah.
They said, holy S, gives properly formatted long responses using the exact uncensored word.
Yes. And notice what they focused on there. Properly formatted. That's the user validating the KL divergence score. Usually when you uncensor a model, it forgets how to do markdown. It forgets bullet points. This user is shocked that the model is still acting like a professional assistant, just a remarkably foul-mouthed one.
There's another one for Qwen34B calling it the best unquantized model runnable on 16 GB VRAM. The community is just flooding Hugging Face with these things. The notes say over 1,000 Heretic-generated models have already been published.
That number is significant. It shows a huge pent-up demand. The big labs, OpenAI, Anthropic, Google, they spend millions trying to align these models to make them safe. And here's a tool that undoes that alignment in 45 minutes and spreads 1,000 variants into the wild.
It's a game of whack-a-mole where the moles are multiplying exponentially. But it's not just about, generating anarchy, right?
Yeah.
There's a legitimate scientific angle to this.
Oh, absolutely. The expert side of me loves this tool, not for the uncensoring, but for the visualization. Heretic includes a whole suite of interpretability tools. It helps us see how the model thinks.
It mentions generating plots of residual vectors and using something called PackMap projection.
PackMap is a way of taking these massive, multidimensional concepts vectors with thousands of numbers and squashing them down into a 2D map that a human can actually look at. And Heretic can generate these even as animated GIFs, showing how a thought transforms as it moves through the layers.
So you can literally watch the refusal happen.
You can see the trajectory, you can see the exact moment the model decides, whoops, that's a bad topic, and just veers away. The tool also calculates these geometric metrics, cosine similarity, geometric medians.
I saw that table in the source. It aligns the harmful and harmless residuals.
Right. It lets a researcher ask, okay, geometrically, how far apart is bomb from baking soda in the model's brain? And, more importantly, does the model treat them differently in layer 5 versus layer 20?
It's like an fMRI scan for an AI.
It really is. By identifying the geometry of refusal, we aren't just learning how to break it. We're learning how the model structures morality, or at least its training on safety,
It turns the black box into a slightly translucent box.
which is arguably more valuable than the uncensoring itself.
So let's zoom out here. We've got the orthogonalization, the floating point indices. We've got the accessibility 45 minutes on a gaming PC. We've got the scale, thousands of models. What's the big picture here? Why does Heretic matter to someone who isn't trying to jailbreak a chatbot?
It matters because it represents a shift in power. For the last few years, the narrative has been that AI alignment is this grand, impossible problem that only the gods of Silicon Valley can solve.
They hold the keys. They set the governor on the engine.
And they tell us it's for our own safety. And what Heretic proves is that the governor is actually pretty flimsy. It proves that safety alignment, as it's currently done, is superficial. It's just a thin layer of paint over the model's true capabilities.
And that paint can be stripped off in the simple script.
Cheaply and automatically. It creates a right to repair dynamic for AI. If you download the weights, you own the model. Heretic gives you the screwdriver to actually tune it.
Yeah.
It means that no matter how restricted the official release is, the community can and will create a baseline version that speaks freely.
It ensures that safe AI isn't the only option out there. It keeps the ecosystem honest, in a way. If a model is biased or overly sensitive or refusing to answer history questions because they're controversial, the community can fix it.
Or break it further. That's the double-edged sword of open source. But the genie is absolutely out of the bottle. You can't hide the refusal direction anymore. We know where it lives, and we know how to cut it out.
It is a fascinating and maybe slightly terrifying time to be watching this space. The tools are getting sharper every single day.
And the models are getting smarter. It's an arms race.
I want to leave you with one final thought today. We spent a lot of time talking about that floating point direction index, how Heretic can find the refusal signal hiding between the layers. It isolates that specific mathematical vector for, I should not say this.
Right. It isolates the inhibition.
So if we can use this math to isolate refusal with that level of precision, what else is hiding in there? The model has directions for everything. What if we could isolate the vector for creativity or empathy or long-term planning?
Or political bias.
Exactly. Could the next version of Heretic allow us not just to uncensor a model, but to tune its personality, to turn up the dial on its logic or turn down the dial on its hallucinations?
We're moving from just training these models to actually engineering their psychology.
The hood is open, the engine is running, and we're just now figuring out what all the wires do.
Thanks for listening to this deep dive into Heretic.
It was a pleasure.
We'll see you next time.